Hello students, today we are doing couple of questions from magnetic field. I have done couple of questions from magnetic field. I hope you have seen and you have tried those questions as well. So let's try these two questions. These questions again from force in magnetic field. Let's try the questions now.
Alright students, I hope you have tried the question. Yes, let's read it now. A proton with 2 mega electron energy enters perpendicular to 2.5 Tesla magnetic field. Mass of the proton is given and the magnetic force on the proton and the charge also given. Right. So basically to find the force on a charge, it should be a moving charge. The equation is this. Right. So then we need to apply the values. P is given, done, and the charge of proton is given. We know that sine theta, it's V is not given, that we need to find, and sine theta, of course, they are telling it's perpendicularly, so it's sine theta equals 1, right? So we need to find the value of V here. So how do you find the value of V? And here you can see they are giving us the energy of the proton. That means it's moving energy, right? So it's basically kinetic energy, half m v square. That should be equal to 2 mega electron volt. Actually here now we have to convert mega electron volt into joules. So how do you convert it? 1 electron volt means charge of an electron 1.6 into 10 to the power minus 19 into 1 volt. So basically 1.6 into 10 to the power minus 19 joules is 1 electron volt. So it's 2 mega electron volts. What we have to do is we have to multiply it by 2 mega 10 to the power 6, of course, and 1.6 into 10 to the power minus 19, right? We have half into the mass of the proton, 1.6 into 10 to the power minus 27, then V square, right? Let's do the simplification now, right? So 1.6 and 1.6 cancel off, 2 goes all the way there. So 4 into 10 to the power 6 into 10 to the power minus 19 divided by 10 to the power minus 27 equals V square, right? So 4 we can keep here, and 10 to the power minus 27, that goes up, then 10 to the power 8, right? 6, 14. Let's see whether it's correct. 27 goes up, that plus 27, 19, 8, yes, 14. So let's take the root value of this. So we are getting V equals, yes, 2 into 10 to the power 7. Now we have the velocity. What we need to do is we need to apply it over there, right? F equals PQV sine theta. Then value of B, it's 2.5. Then the charge 1.6 into 10 to the power minus 19, right? And the velocity, yes, we have found it, 2 into 10 to the power 7, right? 2 into 10 to the power 7, 2 into 10 to the power 7, that's it, right? Yeah, we have all the values. 2 into 2, it's 2.55, 1.6 into 10 to the power minus 19 into 7, 10 to the power minus, it has to be 12, right? Yeah. So 5 into, it's 8 into 10 to the power minus 12 Newton. Yes, we have the answer. It's the fourth answer, right? Right, students, moving into the second question. I hope again you have tried it. If you have tried and you have done the question, that's great. AB is a straight long conducting wire carrying a current 20 amperes. 20 amperes. Okay. CDFG is a rectangular conducting loop carrying a current 10 ampere. Here we have 10 ampere. Its length is 20 centimeters and breadth 9. And the line AB and CG parallel to each other and separated by 1 centimeter. Okay. Find the force on the rectangular loop by the wire AB, right? So basically here what happens is a magnetic field is created by AB wire is on here. So we need to apply right hand grip to find the direction of magnetic field, right? So here from this let's apply right hand grip and we get it on the wires. So here slide this, so it's on the wires. Right. Then we need to check what are the rods, the wires actually that we have the magnetic force, right? So apply F equals BIL, that's the equation. We need BIL sine theta, and for that actually we need to check CG of course that's current parallel, and of course we need to find the direction of forces first. So let's check the direction of forces first and then move into the resultant force values. Right, now let's take the resultant force. So when we have, see in the color, when we have force on this, let's alright, to find the force of course we need to apply left hand rule. So let's apply the left hand rule over here then, right? Then we can see the field goes in and current goes up, field goes in and the current goes up, the force will be created in this direction in CG, and for DF it's in this direction, right? Let's apply it again, right? Field in and the current goes down, yeah. And for GF of course field in, current goes downward, left hand direction, yes, field in, so force downwards. And on this of course force goes up, right? And force on these two we can assume it's equal, CD and GF. So basically the resultant force will be F and F, so the resultant force will be 0, and only on CG and DF we have different values because the magnetic field intensity at CG and DF are different because the distance is different, right? So then we need to find the value on CG and value on DF, and we need to subtract the values, right? Let's find the values now. Initially we need to find the value on CG, so let's apply the equation mu naught IO 2 pi r, then mu naught 4 pi into 10 to the 4 pi into 10 to the power minus 7, I current is 20, divide by, only the R value will differ, right? So 2 pi for first it's 1 into 10 to the, we need to apply in meters, remember that. So with the simplification we are getting 2 pi cancel off, we get 2, and here we have 20, so it's 40 into 10 to the power minus 5, it's 4 into 10 to the power minus 4, the value of P here, right, on this. So then what we need to we have to apply the F equals BIL equation on CG, right? Let's find the magnetic field intensity at DF as well, right? Right, for DF again mu naught, that 4 pi into 10 to the power minus 7, current same 20, only the R value will differ, we know that, 2 pi. The R value, total R value will be 10 now, right? 10 into 10 to the power minus 2, right? So 2 pi, this cancel off, 2, again we get 40 into 10 to the power minus 7 into, here we get 10 to the power minus 1, that goes off, that becomes 10. So it's 4 into 14 10 to the power minus 6, that means 4 into 10 to the power minus 5, right? we have that value as well. Now we have both B values. What we need to have find is we have to find the forces on CG and DF. Let's find the values now. Right, now we have the magnetic field intensity. Let's find the values for force. If this is the equation we need to apply, BIL sine theta. So B 4 into 10 to the power minus 4. The current 10 amperes, current through the loop 10 amperes, and the length we are given, it's 20 into 10 to the power minus 2, because it's in centimeters. I need to convert it, and sine, it's actually parallel to the plane, so it's sine theta equals 1. Let's get the value then. That's 4 into 20, it's 80. 10 to the power minus 4, 10 to the power minus 6, and 10 to the power minus 5. So it's 8 into 10 to the power minus 4 Newton. And let's apply for the other side. Right here. 4 into 10 to the power minus 5 B I 10 L 20 into 10 to the power minus 2. So the only difference is this 10 to the power minus 5, right? So the value will be 8 into 10 to the power minus 5 newtons, right? So then we need to find the difference. Let's find the value now. So it's 80 into 10 to the power minus 5 minus 8 into 10 to the power minus 5. So we get 72 into 10 to the power minus 5. It's 7.2 into 10 to the power minus 4 Newton. Let's check the values now they have given. Yes, 7.2 into 10 to the power minus 4. That's the fourth answer. Oh, of course, they are giving us two different directions. Actually, it's in this direction.
Students, as we all know, practice makes it permanent. So just keep practicing in the correct way, right? Because practice makes it permanent. So if you practice it wrong way, and it'll be permanent, right? So keep practicing in the good way and try lots of questions, make it a skill.